aim to learn more about proteins. Learning objective. You will learn about proteins, structure of proteins, denaturation of proteins, types of proteins and its importance. Learning outcome. By watching this video, you can understand how protein works and the importance of proteins in your diet. A very pleasant welcome to all. Now we will go through the topic proteins. We all know that proteins are the building blocks of body tissues. Let us now poke our nose into the conversation of our friends to know more about proteins.
Hey, where are you going the early morning, Aaron?
I'm off to the market. Recently, I've been having some physical problems, so I went to the doctor yesterday and she suggested to eat some protein rich items.
Okay then, I will come too. I have to do some grocery myself.
Yeah, sure, come on.
Good thing I saw you. I almost forgot.
Meanwhile,
Hey, isn't that Adul?
Yeah, seems like he bought many stuff from the store.
Hey guys, it seems like a long time that I have seen both of you.
Hi Adul, what you got there in the grocery bag?
It is some protein rich food.
Really?
Yeah, I saw an article on essential and non-essential amino acid, and it says that elders and children will lack some of amino acids and protein. And I thought of buying some.
Huh, wait. What? What are these essential and non-essential amino acids?
Non-essential amino acid means the amino acids which are synthesized in our body and which we not needed to be taken into the body. Whereas essential, which is not synthesized in our body and it is essential for our health. Therefore, we want to take it through our diets. Amino acids contain amino and carboxyl functional group, that is NH2 and COH. Depending upon relative position of amino group with respect to carboxyl group, it can be divided into alpha, beta, gamma and so on. Amino acids are generally represented by a 3-letter symbol. Something 1-letter symbol also are used.
And Aaron, glycine and alanine are example for non-essential amino acids, and valine and leucine are example for essential amino acids. Is that clear?
Oh, now I see. Isn't there something called citarion?
A deuterium is a dipolar molecule, which means it has both positive and negative charge, and overall charge is zero.
Huh, okay. Thanks, Adul and Vaishak. You have been a great help to me. Bye then.
You are welcome. See you soon.
Okay, bye Adul.
5 minutes later.
Structure of proteins. Proteins are the polymers of alpha amino acids and they are connected by peptide bond or peptide linkage. Let us see how the peptide bond is formed.
So the green color is used to represent hydrogen atom, orange color is used to represent nitrogen atom, pink color for the carbon atom, a violet color with a blue spot is for the alkyl group and white color for the oxygen atom. Here we have two amino acids. This is the NH2 part, this is CH and an alkyl group attached to it. This is the carboxylic part. Similarly is in the case of this amino acid. This is the NH2 part, this is CH and an alkyl group attached to it. This is the carboxylic part. So here we are discussing about peptide bond formation. During peptide bond formation, the NH2 group of one amino acid reacts with the carboxylic acid of the another amino acid. So what happens then is that one hydrogen atom gets removed from this amino acid, and from here OH gets removed and you get a water molecule, H2O. So that is eliminated. Now this amino acid moves closer and an amide is formed, that is CONH. So this is peptide bond formation. This is a dipeptide because two amino acids are there.
Classification of proteins. Fibrous proteins. Polypeptide chains run parallel and are held together by hydrogen and disulfide bonds, which give fiber-like appearance. These are insoluble in water. Example, keratin and myosin. Globular proteins. The chains of polypeptides coil around to give spherical shape. These are soluble in water. Example, insulins and albumins.
The very first level of structure of proteins is the primary structure. It is the simplest level of protein structure. It is simply the sequence of amino acids in a polypeptide chain. The next level of protein structure is the secondary structure. It is the local folded structure that forms within a polypeptide due to the interactions between atoms of the backbone. They exist in two different types of structures: beta plated sheet. Secondary structure of proteins where NH groups in the backbone of one fully extended strand establish hydrogen bonds with CO groups in the backbone of an adjacent fully extended strand. Alpha helix. It is one of the most common ways in which a polypeptide chain forms all possible hydrogen bonds by twisting into a right-handed screw with the NH group of each amino acid residue hydrogen bonded to the CO group of an adjacent turn of the helix. Next is tertiary structure of proteins. The overall three-dimensional structure of a polypeptide is called the tertiary structure. It is primarily due to the interactions between the R groups of amino acids that make up the protein. Quaternary structure of proteins. Many proteins are made up of single polypeptide chain and have only three levels of structures. However, some proteins are made up of multiple polypeptide chains, also known as subunits. When these subunits come together, they give the protein its quaternary structure. Here's a recap of what we have seen. This is the primary structure, secondary structure, and finally the tertiary structure.
Denaturation of protein. When a protein is subjected to both physical and chemical changes, it loses its biological activity. It is called denaturation of protein. The native helical structure of protein is lost. The primary structure with the peptide linkages are intact, while secondary, tertiary and the quaternary structure is destroyed. For example, coagulation of egg white on boiling and curdling of milk.
We hope that you have understood the concept. Thank you.